Hello, this is Mrs. Huntley. This is Lesson 10 of Module 4, A Critical Look at Proportional Relationships. You should be on page 79 of your student workbook. Your essential question for this lesson is how can I relate two variables in a linear equation? So I know you're probably not happy that we're adding in another variable. You're probably thinking, I just was getting comfortable with x, and now you're going to be talking about another variable, but I promise it's not going to be that bad. We're going to take it step by step. It's not going to be super clear today, but by the time we get through the second part of the module, it should be a little bit more comfortable, a little bit more clear, and we're going to be working with this for the next several weeks. So don't worry if you don't get it fully today, you will. So let's consider the word problem. Paul walks 2 miles in 25 minutes. How many miles can Paul walk in 137.5 minutes? So what we can do is use a table to organize our data. And if Paul walks 2 miles in 25 minutes, we can start increasing the time that he walks, and proportionally, he should be walking a farther distance. Let's say, for example, we want to double it. In 50 minutes, we're going to assume that Paul can walk 4 miles. If we increase it by 25 minutes again, so in 75 minutes, we're going to assume that he can walk 6 miles. So 100 minutes, it would go up another 2 miles. 125, we would assume 10 miles. So 137.5, that's going up more. We can estimate that it's going to be, that it's not an increment of 25 minutes, it's about halfway, so we're looking at about 11 miles. So that's a way of guessing and checking and using our data. And I'm guessing already that you might have figured out that there's a more efficient way of figuring this out. So let's set up a proportion and see if we can figure this out more efficiently instead of having to fill out a whole table to figure it out. So we have two things that we're dealing with. We're dealing with time, and we're going to let x equal time, and we're dealing with distance in miles. We're going to say that y is going to be our distance variable. So I'm going to, I want to stay organized with my data. I want to make sure that I'm keeping my proportions, keeping my time lined up with time and my distance lined up with distance. So I'm going to put my distance, how far he travels on top, and my time, how long it takes him on bottom. And then I don't know how far he's going. That's what I'm trying to solve. So I'm going to call that y. And we're saying it's 137.5 minutes. So I can use my cross products property. So 25y equals 2 times 137.5. So that's going to be 25y equals 275. Divide both sides by 25, and you get y equals 11, which we were able to get there when we were filling out the table. But this is just a little bit more efficient if you can use a proportion and set it up. We can generalize this and come up with a general rule about when Paul is walking. If we want to figure out how far he goes in any given time, we can set up a general proportion. So if we've got 2 miles in 25 minutes, how many miles in an unknown number of minutes? So again, we'll use our cross products property, and we'll have 25y equals 2x. If we divide both sides by 25, we'll have y equals 2/25 x. So what is that telling us? It's telling us for any given time, we can plug that in for x and figure out how far Paul can travel in that amount of time. So I want to draw your attention really quick to this number here, 2/25. That's the rate he's traveling at. And if you look at our chart here, and I actually started doing this before and then I realized I had something else to say, his distance is going up by an increment of 2 each time here. And the time was going up by an increment of plus 25. each time. 2 over 25, y over x, y over x. This will, I promise, make more sense as we move on, but if you've got it down for now, I will walk you through the other examples, and we're going to work on this again in class on Monday, and then we're actually only going to do half the lesson today. We're going to work together with it on Monday, and then we'll do the other half of the lesson on Monday night for homework. So let's take a look at the next example. Only a table is provided here. We want to know how many miles y can be traveled in any number of hours x. So let's take a look at what we've got here. And I already have the 1, 2, 3, your steps. Please write down the steps, because really, when you have the steps and each one is kind of being methodically solved, it makes sense. So again, our time is x, and our distance is y. Why am I in red? I don't want to be. Okay. So if we set up a proportion, distance over time, 123 over 3, because we're going 123 miles in 3 hours. We'll set that equal to our y over our x. Use the cross products property, so 3y is equal to 123x. Divide both sides by 3, and y is going to equal 123 divided by 3 is 41x. So what does this mean? This means I can plug in any value for x for my hours, and I can figure out how many miles are being traveled. If I want to know how many miles, okay, in the table we've got 3, 6, 9, and 12. Say I want to know how many miles are being traveled in 5 miles. I can plug in 5 for x and say 41 times 5 is equal to 205. So he's going 205 miles in 5 hours. Obviously, it's 41 miles per hour, so this is no longer Paul walking unless he's speed walking like a crazy man. Actually, I don't think it's humanly possible. I know it's not humanly possible. So this must be a vehicle or a scooter or something like that traveling at 41 miles per hour. Okay, let's move on to page 80. Page 80 is talking about Alexa. Alexa walked from Grand Central Station on 42nd Street to Penn Station on 7th Avenue. The total distance traveled was 1.1 miles. It took Alexa 25 minutes to make the walk. How many miles did she walk in the first 10 minutes? So let's take a look at this. Again, let's let y be our distance. And let's let x be the time. So the distance she's traveling, 1.1. The time it's taking her to travel, 25 minutes. We want to know how far she traveled in 10 minutes. So I can set this up. I don't know how far she traveled. That's the distance in 10 minutes. Use the cross products property. 25y equals 10 times 1.1. So 25y equals 11. Divide by 25. And y is going to equal a weird fraction, which I want to look at as a decimal. It's 0.44. So it's about 4/10 of 1 mile in 10 minutes. So I can answer the question. Alexa walked about 44 hundredths of a mile in 10 minutes. But I wonder, did she really? Same thing with like the driving one that we solved on the other page. I wonder if maybe Alexa, what if she stopped at the ATM to get money and get a Starbucks on her way, and that's why it took her 25 minutes? and she can actually walk much faster than what she did. So this is assuming a constant rate of speed. So the answer above assumes a constant rate of speed. It does not take into account if she had to stop and wait for a crosswalk, or if she stopped at an ATM and got money, or if there was traffic. So we have to assume that she's walking at exactly the same pace and she's not stopping between point A and point B, and we can talk about it then in terms of this type of an equation. So from here on out, we're going to talk about constant rates or average speeds. And the way we could find the average speed is by dividing the distance by the time. So I've been setting it up that way purposely, having the distance on top of the time so that we can figure out the average that way. Average and constant, this book talks about things in terms of constant. For our purposes at this point, the average speed is the constant speed. So to find the average or constant rate, divide the distance by the time. Okay, so let's do the first example together, and then we're going to call it a night. So we're almost done. You can do it. So what fraction, oh wait, Wesley walks at a constant speed from his house to school 1.5 miles away. It took him 25 minutes to get to school. So our distance, oops, our distance is y. X is our time. 1.5 over 25. So the constant rate, or C is what they're calling it here, is 1.5 over 25. You want to know how many miles he has walked after 15 minutes. Let y represent the distance he traveled. Yep, we already did that. After 15 minutes of walking at the given constant speed. Write a fraction that represents the constant speed c in terms of y. What they're doing is they're breaking it down, and honestly, it's a little bit confusing. So that's why I wanted to work through this one with you. What they're saying is that's half of your proportion. They want you to come up with the other half of the proportion, which we did up top. So y is our distance. We don't know how far it is. And 15 is our time. So the other half of the proportion, we've got distance would be y over 15. On the next page, on page 81, it says write the fractions. Oops, let me get there. Write the fractions from parts A and B as a proportion and solve to find out how many miles Wesley walked after 15 minutes. See, I told you it was confusing. They're breaking it down just a little bit too far, and it's making it seem too simple after the example we went through together. So what they want us to do is do 1.5 over 25 and set that equal to y over 15. Using our cross products property and multiply and solve. So what I'd like you to do right now is pause the video. I set it up for you. Pause the video, and I want you to solve this proportion. Pause it. Okay, so when you use the cross products property, you get 25y equals 1.5 times 15. So doing this multiplication, 25y equals 22.5. Divide both sides by 25, and you get y equals 0.9 miles. So we can say after 15 minutes, Wesley walked about 9/10 of a mile. Again, assuming a constant rate of speed. So D says, let y be the distance in miles that Wesley traveled after X minutes. Write a linear equation in two variables that represents how many miles Wesley traveled or walked after X minutes. So again, it's using the same first half, 1.5 over 25. And then the second half, again, distance is y, time is x. Cross multiply, 25y equals 1.5x. Divide by 25. And y is going to equal, well, it's going to be a little bit ugly, 1.5 over 25x. And we can leave it right there. So I'm going to call it a night. We will pick this up with some examples on Monday, and we will continue with the rest of the lesson on Monday. I hope you have a great rest of your weekend. Bye.